Smart contracts are self-executing contracts containing terms of agreement between buyers and sellers that are encoded using a programming language. These contracts run on blockchain-based decentralized platforms such as Ethereum. Solidity is the most popular programming language on Ethereum. In this video, we introduce LATTE, a tool for visually creating and deploying smart contracts, that is designed for non-programmers or novice users who are not familiar with Solidity. LATTE is designed based on two key principles, namely, effortless creation of smart contract without writing Solidity code, and facilitation of gas-aware formulation of smart contracts. We shall demonstrate these features using a reference contract available in the Solidity documentation. This is the Solidity code for a voting smart contract and is used to ensure the transparency and fairness of an election. In this smart contract, a chairperson will deploy the smart contract and he is in charge of overseeing the voting process. The chairperson is assigned in the constructor, which is called when he deploys the smart contract onto a blockchain node. The chairperson can add possible proposals to the contract and give other people the right to vote. The required statements here ensures that only the chairperson is capable of calling the add proposal and give right to vote function. The vote function can be called by anyone with the right to vote and has not voted yet. His vote will be added to the proposals mapping object which stores the vote counts, and the winning proposal function can be called by anyone to find out which proposal won. The delegate function allows a voter to give his vote to someone else to vote in place of him. In LATTE, the global state tab is used to create events and structure. The constructor is associated with the initial state tab and the rest of the functions will each be associated with a build tab. LATTE is able to infer the types of the global variables based on the user-defined logic. For brevity, the demo shall show the steps to formulate the constructor, and the three functions highlighted here. Note that other functions can be constructed similarly. First, we will connect to localhost 8545, which our test blockchain node is running on. The global state tab represents details of the smart contract that are not tied to any functions, namely events and entities. Declarations events can be thought of as announcements that something has occurred to the rest of the blockchain. Entities are ways for users to group data together in a data structure. Events and entities have to be declared here so that they can be used later. The back button allows the user to go back to the connection page, while the load and save buttons allow user to load an existing contract or to save the current contract. The generate code button generates and saves the Solidity smart contract. User can deploy their contract onto the connected blockchain node using the deploy button. Now, we create a voter entity that shall be used later. This entity consists of four variables, namely weight, voted, delegate and vote. All tabs other than the global state tab correspond to a Solidity function that can be called by external users. All of our build tabs will have the same visual structure containing a function input box, a checking phase box, and an action phase box. The function input box defines the parameters that must be given to the function when it is being called. The checking phase box shows the checks that will be done before the function is run, and they correspond to require statements in Solidity code. The action phase box contains the drag and drop diagram that will be used to define the logic in the function. On the left we have the node types that can be dragged onto the diagram. We start by building the action graph for the constructor. Here, we use the assignment node to assign the message center as the chairperson. Every action graph contains a start node which signals the start of a function. The output port of the start node is then connected to the input port of the next node. The connections informs LATTE on the sequence of statements in the function body. We create a chairperson object to be stored in our mapping. The value of weight is set to 1 while that of voted is set as false. Then we use the assignment node to assign the voter details for chairperson as chairperson voter. The assignment node is then connected to the chairperson voter entity node. To create the add proposal function, we first create a new tab for add proposal. The function takes in a proposal parameter and checks that the function caller is the chairperson. Observe that LATTE automatically identifies certain natural language keywords such as message sender in a user's input and converts them to Solidity code. Then it adds the proposal to the vote count mapping. The user can also enable advanced mode in the settings page. This allows him access to features that significantly reduce gas. We will demonstrate advanced mode with the vote function. In the vote function, the function takes a proposal name parameter and checks that the voter has a right to vote and has not voted yet. These two checks are indicated in the checking phase. The checking phase allows user to specify necessary conditions that need to be satisfied before a function is executed. If these conditions are not met, a user-specified failure message is returned. For the vote function action diagram, we declare that the caller has voted and assign the proposal name to his vote. The user can also declare a variable to be local if it is not being shared with other functions and other functions do not need to know of its existence. This reduces the amount of gas needed to store the variable. We store the voter as a local variable here. We use the assignment node to assign the voters voted to true, and also to assign the proposal name to the voter. Each node is connected to the previous node in the action diagram by drawing an edge from the outgoing port of the previous node to the incoming port of the current node. Then, we add the next assignment node which increases the vote count of the proposal by the voter's weight. We now demonstrate the use of the conditional node. Here, we use the conditional node to check if the proposal has the most votes. The conditional node presented by a diamond shape has incoming ports at the top and on the left. The true output port is at the bottom while the false output port is on the right. The current proposal will be the winning proposal if it has more votes than the previous winning proposal. Observe that we inform LATTE of the correct code sequence by connecting the true port of the conditional node to the incoming port of the winning vote count assignment node. In the true conditional branch, the winning vote count is updated with the proposal vote count and the winning proposal name is set as the current proposal. Next, we create the winning proposal function. In winning proposal, we simply return the winning proposal's name. Note that LATTE can automatically detect whether a function writes to the blockchain. Functions such as the winning proposal are assigned as view. We can also view the gas usage trends of the smart contract by clicking on the View Gas Usage button. The current gas usage and the gas usage history will be shown. We can then click on the Generate Code button, choose a file name and save it. We can see the smart contract that was generated by LATTE here. Observe that the code generated by LATTE corresponds to that from the Solidity documentation for the functions LATTE created. In the smart contract code, the view keyword indicates that the associated function performs read-only task. We can also deploy it to the blockchain that we connected to earlier by clicking the Deploy button. LATTE is intentionally limited to prevent cluttering of the user interface so as to minimize user confusion. As the target user is a novice user or developer, any complex functionality will have to be added manually through code. LATTE's main focus is to maximize user-friendliness, thereby facilitating smart contract development without programming or Solidity experience. We have demonstrated some of the major features of LATTE which visually represents and simplifies the concepts in Solidity smart contracts. User interfaces are crucial to the growth and adoption of blockchain, and LATTE will help to simplify learning and development on the blockchain and make it less intimidating to new developers.